So, as the title says, I'm going to talk about middleware and its place in the world of cloud and mobile. Although I'm representing JBoss and Red Hat, I'm not really going to bang the drum too much about all the great things that we're doing. I'm going to try and make this as an objective presentation as possible, because I truly believe that with or without JBoss and Red Hat, what I'm about to present is pretty much inevitable and will happen. And it's going to need a lot of input and feedback from you guys and the wider middleware and Java community over the next few years. So in this talk, I'm going to start by giving you a quick overview of where we are today in the world of hardware and software. What does mobile and cloud mean, and also ubiquitous computing, which I actually think is a much more general term to encapsulate everything that's going on in cloud and mobile today. And as I said, I'll touch on the hardware and software forces that have really, we might think of them as really only being active over the last few years with the rise of iPads and Android devices and iPhones, but they've really been active for at least 40 years. And then what does this mean for middleware? Like I said, I'm not going to concentrate too much certainly on JBoss and on Java. This is something I think that is going to impact non-Java middleware as well. But I will give an account of what I think it does mean for Java, the ecosystem, and standards. So let's put everything into context. So the devices that you see on this slide here are from 30 years ago. Looking around the room, I'm sure there are the majority of people in this room probably don't know what those things are, or may have seen them in museums. That's an original Ethernet switch. This is a 5¼ floppy disk that you could carry around, and it was about that big. And I can't remember how much you put on it, something like 1.5K, maybe not too much more. That's a Motorola 68000 CPU. It was at the heart of many PCs of the day, from the Atari through to later devices. You also had the 6502 processor, which was an 8-bit processor in the BBC microcomputer here, which, at least in the UK, really kicked off the PC area. And also, given that the device was driven in many ways by ARM, which stands for the Acorn RISC machine, it also had a very big impact on the world we're in today, given that ARM pretty much powers the mobile industry. And that there is a ZX81. 1K memory, 16K memory extension pack if you manage to stick it on the back and get it to stick. But even without the 16K memory pack, people were writing games of chess in 1K. I challenge you to do that today. So this was 30 years ago, and everyone was thinking, this is a new horizon, this is fantastic, this is where we're going to be for the next few years. Now if we fast forward, we have machines that by default, we have smartphones that have 512 mega memory as a standard, with many gigabytes of storage on them. That little red thing down there is a 256 gig USB stick. It was announced about 1.5 years or so ago, and there are more of them out there now than there were 1.5 years ago. And I've already seen announcements for a 1 terabyte USB stick. That's a 100 gig Ethernet switch. Hopefully most of you have seen or at least heard of those things. Your smartphone, 64-bit quad-core processor. If any of you have smartphones in your pockets that are, let's say, between 2 and 3 years old, I pretty much guarantee you that they have more power than a mainframe device of between 15 and 20 years ago. And that's sitting in your pocket now. And Wi-Fi is, certainly in the US, is throughout many, many cities. So we take connectivity for granted. What this shows really is that shouldn't come as a surprise, certainly to the people in this room. The times really have changed a lot. There are now more mobile devices on the planet than there are people. And if you just count processors, so that's things that are in washing machines to cameras, as well as obviously in laptops and mainframes and supercomputers and smartphones and whatever, there are 4 times the number than there are people on the planet. I'm pretty sure that was true when we were only like 6.5 billion people. I'm pretty sure it probably is now that we've passed the 7 billion human beings on the planet. And the interesting thing is that most of these have TCP stacks, so you can connect to them. They are networkable. Whether they're connected to the network all the time or not is a different thing. And again, just to kind of hammer home what I said earlier about the supercomputer, that under that sub-bullet there, here's an example of a 16-bit microcontroller. It's a sensor, and this data is actually about 2 and a bit years old now. And back then, this thing was 1/8 the size of a penny, so probably about that big. It could handle over 16 concurrent sensor inputs, and it had more horsepower than a VAX workstation that I was using in 1986. And it cost a hell of a lot less than the VAX workstation that I was using in 1986. And already there are over 30 million iPads in the world, probably a few more than that if you just count pads of one form or another. Analyst report at the end of last year predicted that by the end of this year, 50% of US-based people would have a smartphone in their pocket of one form or another. And that compared with 10% only 2 years or 3 years prior to that. So everybody has access, at least in first world countries, has access to a significant amount of personal compute power, and it's not that expensive. The cost on a per gigabyte for storage has dropped dramatically from 15 years, 20 years ago of thousands of dollars per gigabyte to now only a few dollars per gigabyte. And that cost is only going to drop. Processors is pretty much the same. And here's an example of the kind of devices, some of them are obvious, but some of them aren't, that have processors in them. You've got your car engine management system, obviously you've got your laptop, your smartphone, you've got cameras that have these kind of processors in them as well. So really, they are all around us. What does this mean for us in terms of the software industry? Well, if you look at or if you remember what I put it up a few slides back on what we had 30 years ago, when the PC came out, people in the mainframe area and certainly people in the workstation area scoffed at those devices. Oh, they're only going to be ever good enough for playing games on. And certainly that's probably where the developers of some of these devices really thought they would land. As I said, the Atari was pretty much a games machine. The Commodore 64 was pretty much a games machine. The laptop concept, if you want to Google this, was originally, or is credited to, I can never remember his name, but look up there, the Dynabook. It was laid out back in the late 60s, and it pretty much is a laptop, but it was originally devised simply for children. The idea was that it would be some way for them to learn to read, learn to do basic school work, but it was not the kind of device that we would envisage today. What has driven the world that we're in today is a combination of hardware advances, but also software advances. If we had not seen the rise of Linux, it would be, I think it would be a significantly different world today. We would not have the kind of machines that we take for granted on our desktop. And I'm not just counting Linux here, but let's say open source Unix, so I would include BSD versions. And Java. I think Java really helped to popularize middleware, and obviously MySQL did very similar for databases. So there's been a lot of software and hardware forces in action to drive the world that we take for granted today. But I hate to break it to you if you're diehard Java fans. Unfortunately, Java's not cool anymore. It was probably cool for about a year and a half, 2 years. So that's probably from 1996 to 1998. But as with everything, you know, new things come and go. And unfortunately today, coolness is Ruby, Scala, Erlang, JavaScript, and pretty much anything other than Java, unfortunately. But it doesn't mean to say that Java's not useful. I mean, there are lots of things that aren't cool that are extremely useful. Mobile, cloud, those are where the hype is, those are where the coolness factors are, and those are where a lot of, certainly I think the next generation of software development and infrastructure are going to be driven from. But, and I just put my name to this, I couldn't find if this actually is a law somewhere, but it's based on Parkinson's law. If anybody knows Parkinson's law, it basically says that the amount of work that you have expands to fill the time available. I reckon that the amount of work that you have fills the power that is available to you as well. So, you know, we started off with games on PCs. We started off with writing a chess program in a ZX81, but it actually wasn't long before people were writing word processors, spreadsheets, and things to really make them useful in your day-to-day life beyond playing Pong or Space Invaders. So, you know, if you look at what we have today on laptops, on desktops, even on your iPad, you know, we've gone from very basic word processors today to what many, certainly of 20 years ago, would have considered publisher quality implementations. And they have been driven primarily by people needing that kind of capability at a low cost on their desktop or in their hand. Games developers have gone from writing, you know, very basic tennis programs where you had a paddle going up and down, and, you know, I don't know how many people ever played that game. I did when it first came out. It kind of dates me, but it really was, you know, it was the Call of Duty of its day. Let me put it that way, okay? They've gone from Pong through Space Invaders to Breakout and, you know, Angry Birds, and now to Call of Duty. And if you look at what actually goes on in those systems, in those infrastructures, and in the programs, they're doing a lot of things that we take for granted in our enterprise middleware space. They're doing things like multi-version concurrency control. They are distributed systems. Look at what happens on, you know, if any of you are using the PlayStation Network or Xbox Live, it's a distributed system. And in many ways, it is also a grid computing system. Again, if any of you looked at Grid when it was at its heyday, you know, 4 or 5 years ago, if you compare and contrast that with something like the PlayStation Network, there are a lot of similarities. And if you actually get a chance to look at the code or talk to some of the developers, you'll see that there's a lot of similarities at that level too. And mobile devices today, they have gone from very basic things that you use for making a phone call to things that you pretty much cannot live without. They contain a lot more personal data these days. They may contain all the photographs of your family life for the last 5 or 6 years. And we're now seeing, you know, a few mobile devices now using NFC, so, you know, near-field communication, where the idea is you will be able to swipe your phone past a sensor and make a payment for something. And in which case you need security, you need, you know, fault tolerance, reliability. Again, you need the things that we are taking for granted and have taken for granted, certainly in the Java space, since the first J2E specification came out. And importantly, disconnected operation is the norm today. So a lot of these devices, whether it's a pad, whether it's a phone, you will often run them in a disconnected way. You will not necessarily have 3G all the time. You will not necessarily have Wi-Fi. You will make updates and you will sync that to your laptop or your desktop when you get back home or get back to the office. If you look at research in the late 80s and early 90s, there was a lot of work going on, primarily in academia, on what was called disconnected operation. And it was, in many ways, blue sky research at that point. It was people thinking maybe we might have some devices, maybe 1 or 2 per department that are disconnected at periods and then need to be reconnected. They were not thinking about millions or billions of devices that are primarily disconnected. So, as I've kind of hinted at, the type of application that we are seeing today on these devices, whether it's mobile, whether it's cloud, are increasing in complexity. I mentioned near-field communication, online purchases through the web is also inclusive in that. We're getting a lot more peer-to-peer interactions. You're taking out the middleman. It's no longer I have to talk to a trusted third party in order to then do an interaction with you. If I know about you, I might talk to your phone directly. And I believe, which is the real thrust of this keynote, that as a result, enterprise requirements are becoming a necessity. I already mentioned security and reliability for making purchases, whether it's through using your phone to swipe past a sensor or whether it's on the web. These are important things, and they're things that we need to think about now, particularly in the area of mobile devices. It's interesting to note there was a report published, I think it was a week or 2 weeks ago, that says that globally the amount of money that is made by whoever, I don't know, on identity theft is now 4 times the global drug trade, which I think is phenomenal, and it says a lot for the software industry and the hardware industry. And we need high performance, low latency messaging as well. So not just security and identity. Like I pointed out earlier, Call of Duty. Hands up anybody who plays Call of Duty or has played Call of Duty. I'm surprised it's so low given this crowd, but anyway, okay. I put my hand up there as well. If you think about what's going on there, you've got multiple people, depending on whether you're using the PlayStation version, it can be in the low 20s. I think if you're using the PC version, you can have maybe 100 or so concurrent users on this at the same time. They work well because you have this real-time or near real-time experience. Just imagine what would happen if you had the kind of network latencies that we used to experience back in the 80s, where 100 milliseconds for a response on a local area network was considered to be extremely fast. You would not be able to do that sort of thing today. So, high performance, low latency, reliable messaging is critical for these kind of applications. And if you're doing database updates, whether it's for payment, whether it's for updating your personal information on your local device or on a distributed device, you need things like transactions to ensure that if there is a failure, that the update either happened or didn't happen. And we're also seeing, certainly on mobile, where you're getting more and more applications on your device that are written by the same vendor, you're getting to see, starting to see more and more of these apps actually communicating in the back end. So you you go into one app and you make a reservation, and that app may communicate with your calendar and actually add that reservation to your local calendar, as well as to the remote server, let's say, where you were making the original reservation. So we're getting a lot of inter-app interactions today, and as soon as you start moving down that path, you're moving into a very workflow type environment. Do this, and if this fails, do this. If it doesn't fail, move on to the next step. So I'll be talking quite a bit about mobile, but what about cloud? So I'm assuming absolutely everybody in this room knows about cloud. Hands up if you have not heard about cloud. Good. You could probably leave if you hadn't. So there are pretty much, there are 2 categories of cloud. There are public cloud. Your friendly neighborhood bookstore is probably one of the biggest examples of that. So everything is public. There are private clouds, which is basically where somebody, one vendor or maybe a collection of vendors use their back office environments to simulate the benefits of a cloud, but they keep it all behind the firewall or within some virtual, some VPN that they can collaborate with across a limited number of vendors. Private cloud, although public cloud is getting a lot of hype, I actually think private cloud is probably much more important because it's a lot easier to convince people that it's secure and that your data is secure and that identity is secure and that it's reliable as well if they've been using these systems quite happily for the last few years. Whereas moving it into public cloud, it's difficult and actually getting more difficult given the number of outages and security loopholes we keep hearing about to convince them, yes, you need to take your data and just stick it in the cloud, and we promise, caveat, small footprint on the clauses in the bottom of the agreement, that we won't let your competitor see your data. There's obviously variations between all public and all private, where you can have hybrid clouds, and you can have things like cloud bursting, where primarily your work is being privately housed, but at certain periods of the year, let's say at Christmas, where you need a little bit more compute power, you might cloud burst out onto a public cloud or maybe onto somebody else's private cloud. But public and private offer two ends of this spectrum. But I think, given what we saw at the start of the presentation about the number of devices that are out there, I actually think ubiquitous computing is a reality today. We were talking about it as an industry about 20 years ago, and it really wasn't a reality at that point. It is today, and I actually think that mobile and embedded devices are the real cloud. I think cloud today just means servers, but really I think the cloud is everything. It should encompass all of these devices, because a lot of these devices are a little bit more capable than some of the devices that you can rent today from Amazon. And if cloud is to succeed, whether it's just server-based cloud or this generic cloud, it's going to need these devices because bandwidth is not increasing. I encourage you all to go online and look up something called Shannon's limit, and basically that tells you it's a rule. It's got well-behaved physics behind it to prove that there is an upper limit on the amount of information that you can convey over any given network connection with that suffers from noise, and every network connection suffers from noise. And ultimately, it is going to be impossible for the cloud to continue to be as useful as it is without mobile devices to help it, because we simply do not have the bandwidth and the infrastructure to allow everybody to use the cloud. At the moment, it's working because not everybody is using the cloud. So the devices that we've got, thin clients, rich clients, they're very, very critical to what we need to do in the cloud going forward. And realistically, if all we ever wanted to do with these devices was to have a thin client, then we should have stopped evolving them 4 or 5 years ago. If we're just going to run a browser on it, we should have stopped back in 2007. Like I showed before, that version of Parkinson's law, because we haven't. This is going to happen. People are going to see, I've got a supercomputer on my phone. What the hell else can I do with it other than play games? So I mentioned ubiquitous computing a few times. I just want to put up a graphic to try and illustrate the type of devices that I've been mentioning. We've obviously got, on the one hand, we've got the smartphones and tablets, which we all know and love, and which many, many people here in this room have got. Then we've got things which you can categorize as like field service devices, warehouse devices. So these are devices that somebody who is cataloging a warehouse for the number of books they've got in it, or the number of other stock items they would use. Processors in those devices are extremely capable today. Even though most of that processing power is not used, it is actually cheaper just to give them an off-the-shelf processor than to create a bespoke die factory somewhere in North Korea or South Korea. And field services devices are things like your local gas company or electricity company. If they presumably it's the same outside of the UK, but in the UK they come around to your house and they read your meter, and then they make some updates, register how much fuel you've used, and then they go back to their base and they connect them. So this is the disconnected operation example that I used earlier. And then we've got like embedded and unattended processors. So some of these may never be networked, like the sensor up there. That thing there might never actually be networked or networkable, but it's connected to the network by proxy when somebody comes up and reads it. Or you might have things like the train sensors. So along train lines, there are a lot of sensors to make sure the train is where it says it is. And if it's not, or if it's going in the wrong direction or on the wrong track, then to obviously report that as quickly as possible. And these sensors, I don't know about in the US, in the UK, but certainly in the US, these sensors have, on their main lines have been updated in the last few years to be extremely capable and extremely powerful devices, because they expect to be putting more and more workload on them so that they don't have to be, effectively thin clients anymore. And in mobile, we've got different types of apps. Ranging from very, very thin mobile applications where you're writing stuff in plain old HTML5. So basically, every app you run is embedded in the browser, and it's only the browser that does the work. So everything really runs offline. You may have a little bit of persistence because HTML5 supports that, but predominantly all the work you're doing is being driven by some remote server through the spectrum to native apps, which is kind of what Apple likes to have. And I think most of the apps, even in the Android store today, would be native apps, where you're actually coding the app to native APIs, and the app is running, everything is pretty much co-located on your device. As I said, it's kind of a spectrum, but the reason I put it up there is that it's interesting from a middleware perspective, in that even at the thin client end, you still need middleware for doing the communication, doing the reliability. And at this end, you might even need a lot more, because you're having it co-located, and it may be using more capabilities that the phone has, such as your location, the camera, and other things. But if you listen to the people who are working in this area, or at least you listen to some of the people that are working in this area, cloud and mobile, it's new age. We need new age developers. Everything that went before is bad. It's kind of like back to the 60s with the hippie movement, and I wasn't involved with that. I may look old like that, but I certainly wasn't involved with that. I was not around. But you had, everything was bad. The man was bad. We need to reinvent the world, and start afresh. And in this area, we've got similar things. We're hearing we need new architectures, new implementations, new frameworks, new operating systems. Everything needs to be new. There's nothing new, nothing that we can learn from the last 40-odd years. But then if you look at the type of apps that people are trying to do with these mobile and cloud-based environments, it looks very similar to the sort of things that we have been, again, taking for granted over the last 10 years in Java and longer elsewhere. We've got devices on this end wanting to connect to the data, or more complex apps running in service here, and in the middle, somehow we do integration. How are we doing the integration? And then, as I said, we're seeing more and more peer-to-peer type applications starting to run, and with having more enterprise features in them, where, as I said again, you're cutting out the middleman. There's no server involved. I might want my app on my iPad to be talking to other apps on other pads or on other phones. I saw a demonstration last week by a university in the US who are working on what they're calling like Social 2.0. And basically, it's like Facebook, except that unlike Facebook, nobody maintains the data except for the people who are involved in the exchange. So I don't use Facebook. The closest I come to a social network is my local pub. But I believe there's something called a Facebook wall, where you put data on it. I'm not a Luddite, believe me. But you put data on the Facebook wall and everybody can look at that data, but Facebook is maintaining that information, and through their terms and conditions, they can make that information available to others, I think. And the point of this is that, or this social 2.0 adventure that's going on, is they want to remove Facebook from this. They want to remove anybody, so presumably even Google would count as somebody they want to take out of the picture. And they want the act of storing that information to not be on a central server, but to be on the devices that are actually interacting. So whether it's your laptop, whether it's your phone or your pad, you have a virtual wall, but there is no single version of that wall being maintained somewhere else. You can see it, and everybody else who's participating in it can see it, but it's only maintained across these devices. So, you know, I said this is a new age, at least if you kind of buy into that. And we're hearing, as I said, you know, this is the death of middleware. There's nothing we can learn. But, you know, haven't we heard this before? And hopefully many of you are certainly old enough to remember some of this stuff. That, you know, web services was the death of middleware. REST is the death of middleware. And you can go back even further. Lots of things have been the death of middleware. But middleware is here today. And it's evolved, but it certainly hasn't died. And I believe that's, you know, if you look at it objectively, then this is not the death of middleware either. I'm not going to go into this in a lot of detail, but basically, you know, we've had over 40 years of developing middleware. Middleware, certainly in distributed systems, it began life in the early 70s when two people tried to connect two computers together. That's where RPC came from. We've had lots of bespoke, non-standard versions here because there weren't standards for defining middleware or distributed systems until the late 80s, early 90s. Then we had standards like ANSA or DCE, and then we've had much more cross-vendor standards with CORBA, J2E, and web services. And one of the things that 40 years of middleware evolution has taught us, I believe, is that there are many, many things in common. It does not matter whether you're doing this on a Microsoft platform, a Java platform, a C++ platform, or going back even further, a COBOL platform. To do real-world enterprisey apps, if you like, you need things like security, high-performance messaging, transactions, replication, and caching. Database, obviously, you've got to store your state somewhere. Obviously, distribution, multi-tenancy. We have spent, as I said, 40 years doing this time and time again. We've gone through one wave after another, and after the waves have settled, what we end up with is very, very similar to what we had before, but maybe in a slightly different language. So what I believe this means is that middleware is required regardless of the deployment platform. So it doesn't matter whether it's just mainframes or whether it's laptops and mainframes or mini computers or workstations. You need some form of middleware. We definitely should not be tying the definition of middleware to any one particular implementation. So I am not saying that we need Java EE, if you like. Although, as we'll see in a minute, I think that's actually a pretty good implementation going forward. But I'm trying not to tie this to any particular implementation. And I think it's extremely important that mobile and cloud development does not become new silos that work kind of, you know, with blinkers and ignore everything that happened before, because there is a lot that we need to learn, and that those developers and communities need to learn about what went in the, or what's been going on in the past, both mistakes and positive things. And a bit like middleware is needed everywhere, I think enterprise requirements are also needed everywhere. I showed you some examples of things like, you know, needing transactions and security. Those things don't go away just because you move to the cloud. In fact, you know, if you do look back at what's been happening over the last 6 or 9 months, in any way, I think they actually make more sense in the cloud than anywhere else, particularly security and reliability. So cloud and mobile are not the death of middleware. There are many common traits for both with what we might call traditional middleware, if you like. Obviously, you know, Java's not the only language. I said at the start that I didn't want to just concentrate on Java, but, you know, for this community, I think, you know, Java still makes a very, very good basis on which to build. It may not be cool, but it's still extremely useful because there is a lot of excellent middleware out there already, whether it's from us or whether it's from others, working in Apache, for instance. There's lots of good middleware out there today. And obviously, we have lots of non-Java-based languages that run on the JVM, whether it's Scala, whether it's Salon that we heard about yesterday. Ruby runs, and there's now even an Erlang variation that runs on the JVM. So the JVM is fast becoming like the new operating system, if you like. People are porting lots and lots of lots of applications to the JVM. And I think that's good for the JVM, and certainly it's good for the Java community that's already invested a lot in Java middleware. And I think one of the big problems we have in cloud and mobile at the moment is the lack of standards. And I think Java and its standards actually help us here. I think that hopefully this doesn't come as a surprise. I actually think that we shouldn't be thinking about revolution here. We should be thinking about evolution. We cannot afford as an industry to do what we've done over the past, particularly moving from things like, for instance, Corba to J2E and stop the world, rewrite everything because we want to in a completely new language, even if it was running quite happily in COBOL or C++, and then start again, because that takes a lot of time. And we really shouldn't be doing that today. Yeah, Ruby's great, but we don't really want to write a transaction service in Ruby or a security implementation in Ruby or a module system in Ruby. Let's take what's already out there. And I think it's important also because, like I said, fault tolerance, reliability, they're extremely important. We have good implementations of that today. And if you look at ubiquitous computing, whether you just focus in on cloud or whether you focus in on mobile, there are many things that are missing today. I already mentioned various issues that we've seen, like, for instance, the more general problem of identity theft. But there are a lot of things that are missing that could be leveraged from the Java community, from our community. Trust is extremely important. Trust is measured in a number of things. Is the service doing what I think it should be doing when it should be doing it? Is this service provided by somebody that I can trust rather than somebody who is spoofing me? Are these services actually living up to the quality of service? Are they giving me the right level of reliability? Are they giving me the right number of messages a second? Again, these are things that we, in many ways, certainly in SOA, which is something else that was hyped for a few years, that we take for granted. We have good implementations of these. They may not be directly usable in some mobile environments. They are directly usable in cloud. But even if they're not directly usable, we may be able to take that knowledge, take those implementations, and factor them in a way that allows us to keep evolving them rather than, as I said, stop the world and start from scratch. I did mention that I thought EE6 is a pretty good basis. Now, this and the next slide are probably my only two Java and maybe JBoss specific slides. I think EE6 really is a good implementation. If any of you have actually looked at EE6, then hopefully you'd agree. If you haven't, take a look at it. It is a significant advancement over EE5, particularly in the area of like CDI. And there are other things like JAX RS and bean validation, but CDI, which we led, Gavin King was was actually driving the expert group for that. It's been credited a lot over the last couple of years, the Java one that we were at and the Java one before that, with simplifying the application developer's burden for developing complex apps in an application server. And it was also developed in a much more open way. Yes, it's not a great open standard at this point. We're evolving that with things like JSR 348. But there was a lot more involvement from people outside of expert groups and outside of the executive committee for pushing EE6. And you can see that if you look at it. So I think EE6 is actually a pretty good basis for us to work. Certainly in the cloud, maybe it needs more tweaking in mobile, and I'll come to that in a second. And if you remember the picture I had before about what people are wanting to do with these devices and back-end systems, if you take that say, turquoisey box and you stick an EE6 implementation in there, whether it's JBoss 7 or some other application server, you find a lot of these things are taken for granted. You get REST, you get, you can get a lot of analytics, you can get a lot of management as well. And as I said, we've got more non-Java-based languages running on the JVM as well. Of course, there are people who say Java EE is too bloated, and we did see that a few years ago with some versions of the standard and also some implementations. But we need to now kind of put the history behind us and start moving on and stop tying standards to implementations. Let's look at the standard and take it away from the way in which it has been implemented in the past. And if you want to look at some other implementations of a good E6 standard, then look at AS7. So, if you haven't looked at JBoss AS7, I, again, would like to encourage you to go and look at it. But it does show that it is now possible to be lightweight and enterprise ready out of the box. We are regularly benchmarking AS7 boot times and memory footprints. There's a competition that's being run now probably for the past 3 months or so. And I think I saw fastest boot time about a week ago of something like a second to boot AS7. It was 3 seconds prior to that. If we're talking about the difference in boot time between a fat application server and a lightweight application server, like Tomcat, and we're only talking in terms of milliseconds, then the argument is dead. There is no such thing as a fat application server. Everything's lightweight now. So what we try to do with AS7 is prove that the EE spec is not bloated. There are good ways to implement it in a fast and performant manner. So what about standards? As I said, we've been trying to reinvigorate the JCP. I think this has a benefit for cloud and mobile. We've been changing the way in which the JCP works over the last year or so. JSR 348, which was just accepted about a week or 2 weeks ago, make some minor changes to the way in which the community process works, and we're now moving on to a next version of that to make even further changes. Oracle at Java 1 announced that they want to merge the Java ME and EE/SE executive committees, and there may well be an update to Java ME. We'll have to wait and see what that is. Unfortunately, I can't tell you what it is. We have seen a lot of Java PaaS implementation, so platform as a service, over the last few months. I mean, we've announced ours. If you were at the JUDCon yesterday, you would have seen a few talks on OpenShift. We saw Oracle demoing Glassfish running in the cloud at Java 1. I haven't checked to see if IBM are doing that yet, but I wouldn't be surprised if they haven't, or it's pretty much on the cards. So there's a lot of work going on in pushing Java into the cloud. And again, at Java 1, there was demos on Java FX and pushing Java onto mobile devices, and there was a demo of it running on the iPhone as well. There's work outside of the JCP on standardizing things that are important to us, whether it's an OSGI. There's also work still going on in the OMG, if anybody's old enough to remember or even participate in that. But I think really one of the big changes that we've seen, and one of the ones that will probably impact cloud and mobile most over the next few years, is open source. Open source is a great way of getting immediate feedback on the direction in which you want to go, whether it's with a specification or whether it's with an implementation. And we get fantastic, certainly in our communities, we get fantastic feedback from our communities, whether it's, they don't like something or whether they love it. And it helps to improve our experiences before we get to a standards body. It doesn't matter whether we're going to go to JCP or OSGI. It is vitally important that we only standardize at the right time. If we standardize too soon, you end up with a standard that really doesn't make any sense. So for mobile and for cloud, although people are talking about the lack of standards, I actually think that's to be expected at this stage. We need to get much more experience, and then when we know what we can standardize and should standardize, then we should move on to standardizing. But it's not although it's, I've pointed out there are deficiencies in mobile and cloud, and with existing middleware solutions can certainly help with, it's not perfect. It's not like we can just take what we've been using and developing for the last 10 years in Java and say to the mobile developers, here, use it, it will solve all of your problems and world peace into the equation as well. It won't. There are things that are not right. Scalability and other aspects need to be really modified. Like I said, at one point, a large-scale distributed system was 2 PCs in the 70s. Then it moved up to a few, 10 or so machines. And then it's kind of become 100. And now we're talking about people wanting to use thousands of machines on the cloud. And if you then think about people wanting to do this on mobile devices, it's even more orders of magnitude. So there are a number of key issues that remain. I'm just going to touch on those as I round up. So, building trustworthy systems. I said that today we have extremely trustworthy systems in the enterprise environment, and we do. They're very, very trustworthy. And hopefully, you guys don't really have too much concern with buying a book from Amazon or booking something on lastminute.com, for instance. But if you actually think about it, we still can't make the perfect trusted system. And what would be the perfect trusted system? Well, a perfect trusted system would be one in which it is absolutely impossible for anybody other than an authorized user to access it. Services, you can't have denial of service attacks on things. You can't have your information stolen, even inadvertently. And a perfect trusted system is one that is always available. So, my definition of this would be a one that is almost available is pretty much the same as the one that's available only unavailable for 1 second in 100 years. We do not have that today. In the 1950s, we were talking about 90% availability. Last year, we could get 99.99% availability, which 50 minutes in a year is still not bad, but it's not 1 second in every 100 years. And the key, or one of the key reasons for this, is that despite the fact that hardware is getting more and more reliable, we now have hardware that can self-check and remove paths in the hardware that are unreliable and kind of bypass them. We do not have that in software. Software is still primarily being developed by humans. I don't know of any software that's not, but please catch me afterwards and let me know. And humans, unfortunately, are prone to error. And despite the fact that some universities still talk about computer science, it's not a science, it's an art. And many, many people are really bad artists. I hate to say that, okay? It is an art. People throw together code and hope it'll work. And most of the time it does, but the edge cases are getting bigger and bigger, and a lot of the time it doesn't. And we still have problems with development models. We have, despite new languages like Erlang and things that Scala brings to the table, we have yet to really make parallel programming easy. Automatic programming, automatic parallelism has pretty much won, but if you throw, whether it's multiple machines into the mix or multiple nodes, multiple cores on a processor, it's still harder and harder to get people to actually think about that, what it means to them and to their application, let alone to then kind of develop their application to that in mind. The languages that we have today are still not really good enough. It's really hard to write reliable parallel processing applications that can automatically make use of all of the additional processing power that's there. So the scale-up problem is not solved. And I think that's a good thing because it keeps some of us in jobs for a while longer. And then there's the data problem as well. So I hinted at this earlier with Shannon's limit. It's still really, really hard to have reliable connections and fast connections with the kind of broadband speeds that you might want, particularly if you end up at certain times of the day where your son or daughter and about 50,000 others are playing Call of Duty, and your download speed just goes through the floor. So as a result, there's been a move away from traditional databases as well, which have been developed with a very specific use case in mind of there was essentially one database or one virtual database that might be replicated a number of times, but still one database effectively in a single location. maintaining all of your data, you know, in tables and whatever. There's been a move away from these because it's been shown that at least these current architectures don't scale, particularly don't scale in the areas where you want to store, you know, multi-terabytes of information. You want to do real-time analytics on it. You want to do real-time updates as well, and you want to do it in a way that is fault-tolerant. Traditional databases are not cutting it. Even, you know, when we saw the announcement from Oracle at Java 1 about an entry into, you know, NoSQL, they kind of are admitting that they need to have an offering there. And I learned yesterday that, you know, IBM are doing the same thing with DB2. So there has been this move away from traditional, what you might call SQL-based databases, to other alternatives. And we now have 3, or depending on how you want to call it, 4 categories of these things. We've got what are known as old SQL. This is your Oracles, your DB2s, your MySQLs. Then we have NoSQL, which started off being NoSQL, but has now kind of become not only SQL, where people realize you do need SQL at some point. And now, as of about 6 months ago, apparently we have something called NewSQL, which is the database vendors coming back with a vengeance and saying, well, if we or at least some database vendors, saying if we rewrite our architectures, if we take out contention on locking of tables, if we remove so much contention on thread swapping, we believe that we can come up with SQL databases that actually do scale. You don't need to go to NoSQL, which is eventual consistency. You can maintain your strong consistency with ACID transactions in a manner that is scalable. So that's NewSQL. The only example I know of NewSQL at this point is an implementation from a company headed by a guy called Mike Stonebreaker, who is one of the original SQL gurus, and their implementation is called VoltDB. And he did a demo of this again last week that I saw, and they were reporting figures. They were 60 times faster than Oracle and 8 times faster than Cassandra. So, you know, he thinks he's onto something, started up a company, and they have some customers. So, in conclusion, I think I've overrun slightly. I think, you know, cloud and mobile will continue to evolve. Enterprise middleware is not going to go away. I think it's only going to become more and more important in these areas, particularly as I believe mobile becomes to encompass cloud with ubiquitous computing. I don't think we should be, as an industry, trying to track multiple different platforms. We should try and make our middleware components, whether it's high-performance messaging or security or transactions or whatever, as applicable to these different environments as we possibly can. We should try and embrace and encourage these communities to look at what we've done, and we should try and learn from what they need, because, as I said, not everything we've done will be a perfect fit, but evolving them may be a hell of a lot better for us as an industry and our user base than starting from scratch. I honestly think that the next decade will certainly be defined more by mobile and ubiquitous computing than by anything else. So if you are looking for a career change, maybe that's where you should look. But there are still areas that, you know, need to be addressed, and I've mentioned them already. And that's pretty much it.